Thank you everybody for attending today's webinar presentation. This is the What's New for 2017, going through our Technical Communications Suite here at Hawk Ridge Systems. My name is Scott Woods. I'm the Technical Product Manager for SolidWorks Composer, SolidWorks Inspection, Model-Based Definitions, and Visualize. So this is what we're calling our Technical Communications suite of products. And that definitely includes Composer, Inspection, and Model-Based Definitions. Visualize is a new tool that's kind of new to the family here. It's technically a visual communication tool, or if you go onto the SolidWorks website, it's classified in a visualization bucket. So that one's kind of, it's kind of outside of technical communications, but it is part of visual communications, so we're just going to go and throw it in this bucket for now until it has its own home. So yeah, so again, my name is Scott Woods, and for any of these products, feel free to email me at any time. So I'm going to go ahead and I'll put my email up at the very end. You guys can contact me direct for that. So let's go ahead and kick it off here for what has been added for 2017. So the first product I'm going to go over here is Composer, SolidWorks Composer. And we have a few things new, but keep in mind Composer is a product that is both for, it's a Dassault product, but it's both in the CATIA channel and the SolidWorks channel. So as most of our products are released at the same time, as far as the what's new and things that come up for the new releases, under our SolidWorks umbrella, almost all of our products come out at the same time, and that was a couple weeks ago. Actually, I should say this week technically for everybody. So Composer is a little bit different. We have some things here that have been added. That doesn't necessarily mean that this is the only things that have been added for 2017. Every year we do this, and then right before the first of the year we were surprised with some pretty cool stuff that comes in. So if that comes in again this year, which I'm assuming it will, we'll have another webinar recording, something like that, to go ahead and go over those as well. So we'll go ahead and show what we have now for Composer, and then when more things come up, we'll gather those together and present that as well. Okay, so first thing on the list is CGM outputs and hotspots are now compliant with S1000D, and so if you know what that means, that is probably exciting. So if you are creating CGM outputs currently, in the past they weren't technically compliant, but now we can go ahead and specify that in the output, and it should be compliant now. So if that was something that was concerning in the past, now we're compliant, and that goes for the hotspots as well. Okay, so first thing that we will like to show in the software here is customize the assembly tree. So new in 2017, SolidWorks has added the ability to overload the assembly tree names, which really just technically means to change the names of the parts and assemblies in the assembly tree. And let me go and show what that is. Okay, so here I have a model, and you'll see in the left the assembly tree names. These are parts and assemblies. Now these guys here, technically in the past they came from the part names or assembly names of the SolidWorks components or whatever components you're bringing into Composer. Now they come in a little bit different, or you have the option of bringing them in a little bit differently. And let me explain this here. First off, if you say merge file into one actor per part, you have that checked. These names, and I'm talking about 2016 and previous, these names come in as the part name and assembly name with that option checked right here. With that option unchecked, the assemblies would come in with the part name. The parts would come in kind of like as a subassembly with the part name. Then anything below that would be the separate bodies of the SolidWorks components, and they would be named the body name that's in SolidWorks. So that's a little bit confusing, but basically with this unchecked, it treats a SolidWorks part as a SolidWorks assembly if it has multiple bodies in there, and the multiple bodies are named per the body names in SolidWorks. Okay, so, and it still comes in that way, and that hasn't changed, but now we have this option here to overload the assembly tree name. So with that selected, we can go ahead and we can key in a meta property here. And by meta property, they're talking about custom properties. So in your SolidWorks assembly, your SolidWorks components, if you have a consistent meta property through all those components in those assemblies, we can call out that meta property and have it specify that property as the file name in the tree. For instance, let's say that you do a lot of annotations, a lot of bombs or something like that, and you want a column that's calling out the part name, but that part name isn't technically the file name. Maybe it's some like part name with a revision on there or something specific to what your customer is asking for, which we hear about a lot. If you have a meta property in your SolidWorks parts and assemblies specifying that, and it can be called whatever you want, we can type it in here, it will interrogate that, and it will list whatever that property is in the tree. And that property would be different for each part and assembly, thus building the tree in that way. So that was one of those things that was real specific. It was asked from quite a few customers, and again, just a way that SolidWorks has kind of listened to the customer base and implemented things like that that maybe not everybody needs. If that wasn't a concern in the past, it's not important to you, but if you were asking for it, it's there now, and it's really convenient if you want to use those meta properties for naming your assembly tree. Okay, so next one on the list is new view name templates and document properties. And this one, again, is another one that's a little bit harder to explain. It's easier just to show, but what it is, and the pop-up Composer again real quick, and I will show the what I'm talking about here before I explain it. So when you go to do a high resolution output, here's our views, and you say that we want multiple images, you're going to save this out as a bunch of images like JPEGs or PNGs or bitmaps or something like that. This option right here actually controls the naming structure of those. Like say they're JPEGs we're saving out. It's going to it was going to control the naming structure of those. And so we have file name plus view name. So right now, if I were to save this out as a group of images, it's going to take the file name, which is this guy right here, the MH Hawk Lifter V2, and then it's going to have view name, so it's going to have that plus view 1 or view 2 or view 3, view 4, so on and so forth. And that's been the standard. It's always been that way, and that has caused some problems in some workflows with some customers. So, and those customers have said, hey, SolidWorks, we need to change this because it's causing us issues. And what that issue typically is that say for instance you have multiple SMG files, so multiple Composer projects for a single project you're working on. Like let's say you had this big piece of machinery, and you didn't want to bring the whole thing into Composer, so you would bring maybe this subassembly, that subassembly over there, and those would be all different Composer projects, different Composer SMG files. And each one of those control a different set of images in your final documentation. So let's say that SMG, which is a Composer file, number 1 controlled images 5 through 15. Number 2 controlled 16 through 32, and number 3 controlled 33 through whatever, 68. And when you open up the SMG number 2 and you want to control that, I remember what numbers I threw out there, I think it was 16 through 32 or something like that, you can say, hey, we want to go ahead and change this. So the view name plus, let me pop that PowerPoint back up, view name or view index plus n or minus n. What that's going to do is that's a variable there. So the plus n, you can do nothing. It's just going to pull out whatever your current naming structure is. But the plus n minus n, what that does, and again, this is a little hard to explain here, but you add that here, and it takes, if you did a plus, let's say you did a plus 10, it's going to take how many views you have, and then the next one is going to be it's going to save out plus 10 of that, so it's going to add 10 to it. So for instance, if I were to save this out right now, and this one has 6 views, my view number 1 will actually be view number 16. My view number 2 will be view number 17, and so on and so forth, it's going to add 10 to that number. If you said -3, and then it would take away 3. So if I had 6, the first one I save out would be view number 3. So again, that's another one you're like, well, why would I ever use that? If you had the issue, the trouble, and you were running into it, then it makes sense, and you're like, okay, well now I know how to fix that, and so that makes my workflow a little bit better. Also, if you're thinking for in the future of kind of improving your process, and right now what we're getting a lot is, and I do this too, we'll take a bunch of different SMG files, dump out the images, rename all those in the folder, and then put them together, which works just fine. But this allows you to set it up a little bit more intelligently, so you don't have to be renaming all those files afterwards, especially if you're dealing with hundreds of images. It just makes life a lot easier. So again, it takes a little bit of playing with it, but once you kind of get that structure and workflow, it does make sense, and it does work out really well. Okay, moving on to the next thing on the list here. And this one is cool. I like this one a lot. Clear colors inherited from parent nodes in assembly. Okay, so let's explain this one. So in the past, when you bring a Composer file, or I'm sorry, a SolidWorks file into Composer, the rule of thumb is that you wanted to color everything per part. So if you had this assembly, and let's pull up Composer, we have this assembly, we look at the parts, drop those down, and do something like this. I'm just going to go ahead and tab through some components here. All right, so we have some parts, and let's say, we got a part there, component here, and you'll see that selecting them in the tree, each one of these components you'd want to color independently in SolidWorks and have no coloring at the assembly level or the sub-assembly level or the top assembly level, because I guess it doesn't really matter too much on those, but it could potentially confuse the coloring within Composer. And so rule of thumb, to kind of like avoid all those obstacles, we'd want to color all the components per component. But now we can color components or parts per component, per subassembly, and per top level assembly, and then control that. So let's say that we had coloring on the top level assembly. I'd come into Composer and I wanted to wipe that out, and I wanted to show the subassembly coloring or the part coloring. I would say Assembly Selection Mode, which is the little tool right there. I'd click on my model, and then I'd go ahead and for color, I'd say Undefined. So let's say that this whole model was colored green in SolidWorks. That was the top level assembly for whatever color, it was colored that for whatever reason. Now we can come in here, we can say, you know what, that's going to be undefined, and now that's going to hop down to the next level, which is subassembly. And so let's say a subassembly here, maybe let's try to find something that's kind of on the outside. I think most of these guys are internal components. Yeah, here we go, for this guy here. And I can go ahead and say for that guy there, the LiDAR, we're going to go ahead and say that is undefined as well, and it's going to show the part coloring. Or we can go ahead and we can have that, whatever coloring it is in SolidWorks, we can have that shown. So there's that. And just kind of go over that one more time. Little diagram here really helps. This one on the far right shows coloring in the top level assembly, coloring in the subassembly, coloring of the parts. So we can import it that way if you want. It's no problem. Wipe out or clear the top level. That's this one here to show the subassembly coloring. All the parts are going to be that color, right? So here all the parts are going to be A, colored as A, all the parts are colored as B, because that's controlling. So it controls from the top down. And so if we wipe out the top level, we wipe out the subassembly level, now we get the coloring of the parts, which is still my preferred method. But my preferred method isn't the same as everybody's, and we get calls in a lot saying, hey, we do all our colorings at the subassembly level. We don't color the components. We don't color the top level. We color the components in the middle, the subassemblies, and they don't come into Composer. Everything comes in gray, or whatever color the default color is. Now that's no longer a problem. We can go this structure here, and we can keep that. Okay. So moving on to the next application. Again, going back to Composer. I expect there's more to come. I haven't got that verified, but we'll keep you posted about that. Okay, so for inspection, so what's new 2017? Inspection doesn't have a whole lot new. It has some good ones here, but really Inspection is a very solid product. It's one of those products that it does a very specific task, and it does it really well, and it's also a pretty mature product. It's been around for a while, so it's one of those products that they're always going to be improving, adding little things here and there, mostly options and default properties and things like that. But let's go ahead and go over what we have. All right, so in the standalone, and I don't think I need to show this, it's pretty self-explanatory here, but actually let me talk about the difference between standalone and the add-in for those who might not know. So when you buy SolidWorks Inspection, which is our first article inspection tool for creating those reports, we have a standalone that's separate from SolidWorks, and we also have an add-in that's in SolidWorks. They're very similar products. You get them both. You don't buy them separately. When you buy Inspection, you get both of those products. And so in the standalone, the mouse will zoom. You weren't able to do before. You'd have to actually go down the bottom right and zoom it that way. It was a little bit different, maybe backwards from SolidWorks. So now it's similar, the same as it is in SolidWorks. So when you're working in both applications, it's the same, which it should be. And they've added that now to the standalone. In the add-in, so this is inside SolidWorks, we have 3 really good improvements. I'm going to go ahead and show all 3 of these at the same time because they are connected in sort of a way that I can show it. So first, let's go and talk about them. We'll show it here. So manually ballooning the drawings. So you might think, well, couldn't we do that in the past? Well, we could in the add-in. We've always been able to do that in the add-in. Oh, no, I'm sorry, the standalone. We've always been able to do it in the standalone, but we weren't able to do it in the add-in. How the add-in worked, 2016 and prior, where you would select the dimensions that you would like to add to the inspection report, notes and all that stuff. So you'd select those and you say create it, and then SolidWorks would automatically assign balloons per those items. Now you can go ahead and say, hey, I want to manually select each one and balloon it at that time. So I can control in which order this drawing is inspected to, and also which balloons go with which dimensions, which is really convenient that we can do that. So that was a big deal in the past that we couldn't do it. Now we could. Now choosing the VDA balloon style, this is another one that was available in the standalone, but wasn't an option in the add-in. And that's a little screenshot of it right there, a little VDA balloon shape. So again, just another one of those little things that a customer had asked for and SolidWorks implemented. So it was in the add-in, wasn't the standalone. Didn't make a whole lot of sense why that was, and someone pointed it out and they go, oh, well, let's go ahead and add it, and now we got it. Preventing balloon renumbering by locking balloons. This is by far the most important enhancement of inspection for 2017. So what this means is that, say that you balloon your drawing for the inspection report. We have balloons 1 through 15. Now you go back and you say, you know what, we don't need to inspect to balloon number 9. You delete that balloon. What would happen is balloon number 10 would become 9, balloon number 11 would become 10, 12 would become 11, 13 would become 12, and so forth to the very end. Which didn't seem like a big deal, but it is a big deal if you've already created an inspection report off of that, you've already printed it, that's on the shop floor, and QC is inspecting to it, and you're like, oh, I just want to delete this. Oh man, now I gotta regenerate that report, now I gotta reprint it, all because I deleted a balloon and nothing matches up now. Where now you can delete that balloon, all the other numbers stay where they're at, and technically that drawing is still up to date with the printed stuff. The printed stuff will still have balloon number 9 to inspect to. You just take a red marker, cross that out, little signature, done. Whole lot quicker than redoing everything. So just one of those little tiny things that really caused a big issue, and we didn't really know about it until it was an issue, and then we're like, wow, let's go ahead and get that fixed. So that is now fixed. So let's go ahead and show all 3 of those right now. Okay. So what I want to do here, and again, this is the add-in for SolidWorks. I'm going to go ahead and say SolidWorks Inspection. Let's go ahead and create a new inspection report. We had a bunch of templates here. I'm going to use our default. And the first one for the naming or the manually ballooning of the items here, that's going to be under Extraction. We want to set that to Manual. So with that manual, I'll be able to select them. The second one here for locking balloons was actually the third one on the list. is right here. And so this is a new little option right here. So with that locked, now we will be able to delete the balloons that we make, and the rest will stay where they're at. If you want them to update like they used to, you just want to go ahead and uncheck that. All right, so checkbox here to accept it, and we're just going to create a real fast report. So now if I go to add characteristic, and I start selecting dimensions, nodes, something like that. One second here. Let's go ahead and make sure that we got this manual. Okay, there we go. Okay, so I'm going to start adding. Sorry, I had this open for too long, so it wanted to save it on me here. But so I'm going to go ahead and just start selecting items. It likes to do that autosave. And when you start selecting components, SolidWorks is not always going to put those balloons. SolidWorks Inspection is not always going to put those balloons where you want them. Sometimes they're overlapping items. I hear a lot is like, oh, you know, I want that fixed, and you can control where they're placed in the options. But really, typically, there's no good place that works for every single selection. So just select them. They'll put them where they go. You can always move them later, which I'll show here. It's not a big deal. It's quicker to do it at the end than for each and every one, because we got to exit out of the tool and things like that. So you just kind of make a bunch of selections for all these parts. If you want to balloons, I want to group some together so I can zoom in and look at them a little bit closer here. So we got 10 total. And so now that I have those ballooned, let's go ahead and we'll go into our balloon styles, and let's show that VDA. So for a regular format, for circle, and it's going to scroll down, and now we got VDA. That's the new one. Hit the checkbox to accept that, and we got our balloons. Okay, now let's say, you know, we look at this and say, well, that definitely balloon shouldn't be there. So what you do is, it's kind of in the way. Let me try this one more time. Yeah, that's good. Another one's a little easier to click on. What I typically do is I just double click it. Hold on one second. All right, let's try another one. All right. That's wanting to do a block. It's okay. I'll show that here in a second. Let's go ahead and delete one real quick. So first off is there. That's what I wanted. Okay, so if I click on a dimension, I was selecting the block. That's all that's going on. I'll show the repositioning here in a second. I just want to show the renaming doesn't happen. So if I delete 9, 10 remains the same. What would happen in the past if 10 would become 9? All the rest would stay the same, but let's say if I choose number 2 there and deleted it, it goes away. Now 1 to 3. So that's that new enhancement there. And now that I don't have the block selected anymore, I can click these guys and just drag it. And how you get out of that is I just hit escape, and if you double click an element there, you can select it and change it as well. So, and that's how you edit the block. So you want to avoid double clicking the balloons. All right, so yeah, and that's it. So it's just that easy. And so let's go back to our PowerPoint. And so that was all 3 of these. So manually ballooning the drawings, that's just selecting each one of the dimensions, throwing the balloons on there. The VDA balloon style, that's that little icon there. Preventing balloon renumbering by locking the balloons, so you can delete the balloons without them repositioning. And just a little tip there that I kind of found on the fly here is you don't really want to be double clicking those dimensions or those balloons, because you'll be editing the block. So try to avoid that too. Okay, so let's go ahead to the next item on our agenda, and that is SolidWorks model-based definitions. Okay, so this is one of our newest products. So if you're unfamiliar with what this is, SolidWorks model-based definitions is to be able to add PMI data to the 3D model. So that's going to be dimensions, annotations, notes, bill materials, all within the 3D view, and then save that out as a 3D PDF. And so it's a way to go drawingless. It's also a way to go paperless. And those dimensions are all driven by DIM Expert. So anytime that you in SolidWorks create anything with the DIM Expert tool, the dimensions and stuff, the PMI data on the model, all that comes over into the 3D PDF or eDrawings using model-based definitions. Okay, so now in 2017, we have control over the accuracy of that PDF. Now there is a measurement tool in the PDF saved out of model-based definitions, and that PDF can be opened with really any 3D PDF player. Most common one is the Adobe Acrobat player. That plays 3D PDFs, and that's compatible with PCs, Macs, mobile devices. Some mobile devices require a 3D PDF viewer. I think my phone, I don't even remember what I downloaded. It's just something off the App Store. It's real easy to locate. Just type in 3D PDF, you download an app, and then that will open up these as well. Now, with that said, because we can control the quality or the accuracy, this is going to control the file size. So the less accurate, the less the file size, the more accurate, the more the file size. The more the accurate, you can actually send that to a supplier and they can measure it and produce it with not a whole lot of dimensions already specified on the model, which is really convenient. If you don't want somebody to be able to measure, like you're concerned about reverse engineering or anything like that, you can go to low. It's going to put it at 0.1 millimeter, just auto tolerance, so it's hard to reproduce the thing with that being right on. Okay, so the 3D PDF template editor improvements. We got a lot here on the list, and so what I'm going to do is I'm going to go ahead and just go through these one at a time. And to do that, I'm going to move that to a different screen so I can see them, and then we'll just go through each one of these and kind of define what they are. Okay, so let's go to a different component. We'll do this guy here, and if you're unfamiliar with model-based definitions, down here at the bottom we have these 3D views, and as we add annotations and stuff, we can put it in the 3D views. So what I want to do, and then once you have that, you can save it as a 3D PDF. It uses a template to save that 3D PDF. So let's go ahead and use the 3D PDF template editor, and we can make your own template here. Now there is a ton of templates that come with this program, and you can choose any of those to modify and then start making your own. And we got something like this. Okay, so the first thing on the list is aligning elements. So anything in here is called an element. Let's say that we have a text, and we have a text like this. You now can select two texts. I can go ahead and say align these guys, and I'm going to align them to like left, right? That's just going to line them up there. So that's the first thing on the list. Copy and pasting between pages. So I have two pages. Let's say I wanted both these guys, I'm going to copy them. I'm going to page 2. I just Control-C, Control-V, paste them, something like that. So we can go ahead and place that there. Okay, and next one is formatting text. So if I click on any text, I now have this new format option here, so I can choose my fonts, my size, coloring. You just have a lot more formatting of that text, as you would expect in most, kind of applications. But this way, you can really control and define your template and really customize it and make your PDF stand out from most of them out on the market right now. Okay, so inserting rectangles. So this is just a little rectangle tool here. I can go ahead and take that and I can insert a rectangle, resize it just like you would a photo. You can choose border thicknesses around the corners and whatever you want to do. And this is just really helpful if you wanted to kind of define an area on the template, maybe throw some text in there, put a border around something. Just a little block tool. Also for this background blocks, if you want to just kind of real estate, define where this set of formatting is going to be, we can define an area with the block, put them in the block. So nice little tool there that's just really helpful. Now locking elements, that's also really nice for your page template, because you don't want to set up a page template and then accidentally click on this block and move it. And so what you can do is hit this little check, this little lock here, and now that's locked, and I'm not going to be able to select it and move it around. So if I have text over the top of it, which I'll explain here in a second, you won't be able to select the other one. So the text in the back moves on to my next my next enhancement here is the order. So now I can go ahead and I can say, you know what, I'm going to bring this to the front, this text, or I'm going to, maybe if I want text to go over the model, I can go ahead and I can bring that to the front as well, and I can put text over the top. Before, it was kind of all in the same plane, which made it real difficult to move things around. Now, just like in a lot of like PowerPoint and stuff, you can reposition those 2D images kind of on different planes. We can do that here as well. Okay, so renaming pages. It's easy as going down to the page, double-clicking it, renaming it. Before, it was just page 1 through whatever. You couldn't change the name of them. Repositioning pages. So let's say I have multiple pages here. I can just take any of these pages, reposition it by dragging it, and reorder the numbering of the pages. Resizing rows and columns in generic tables. I don't think I have a generic table in this template, so let's go ahead and make one. Let's do page 4. We'll do a generic template here. So let's say that we have a template, title block or something, and I just used a generic one there. Basically, what that means is this is like an Excel template, and we can now take these columns and rows and we can reposition them so we can get more area for that text and wrap the text and things like that. So one of those things that is just really nice, just little modifications and customizing of the template. Grouping and ungrouping of elements, it's a new one as well. So let's say that like date and this custom property always goes together. We can go ahead and we can group these guys together. So anytime I click one or the other and move it, I guess there was 2 of them there. Oh, I grabbed the wrong one. There it is. Grab that guy, move it. They're going to move together. So grouping and ungrouping. And of course, ungrouping will separate them so you can move it around. All right, last one on the template editor is inserting elements at pointer location. So I don't know if you've noticed this. I probably should have called this one at the very beginning. But basically, if I say like text and I click somewhere, the text puts there. Before, we would put it up in the corner, which is a little bit annoying because you'd always have to go back to the corner and drag it to where you want to go. It's just nice now that it goes to your pointer location. Okay, so let's bring this guy back down. And current slide, there we go. All right, so next on the list is exporting PMI annotations to step 242 and attaching files to 3D PDFs. Okay, so I grouped these 2 together. These are the 2 most important enhancements of model-based definitions for 2017. And I grouped them together because they kind of go together. So basically what a step 242 file is, if you're unfamiliar with that, is you can save your model with all your PMI data as a step file. And the step 242 includes the PMI information. So any programs out there that read in PMI enabled step files will be able to read in the step file and get that PMI information. So if you send it to your supplier, vendor, whoever it is, and you send the 3D PDF with the annotations and notes and everything, and then also they get a step file with that with dimensions, and they can plug that in and machine it, through CNC. It just makes that transaction a whole lot easier. And if you can reduce the number of drawings that are sent over or eliminate the drawings totally, that just saves a lot of work and a lot of error, because a 3D model is a 3D model, and if you design it or if you manufacture it to the 3D model, it should be more accurate, unless the 3D model is wrong, of course. But that's a whole other issue. But as long as the 3D model is modeled correctly, then your product should be manufactured correctly using this process. Okay, so let's show that real quick. So going back into SolidWorks, and we've got a part here. First, let's throw a couple dimensions on here. So I really like this new basic dimension. It's really nice. You just kind of be able to throw dimensions anywhere, and we'll just throw a couple of them on here just real quick. So you'll see how easy it is to just throw dimensions in model-based definitions. It's just using dim expert. So you throw these dimensions on there and we get something like that, just something real basic. Now I say I want to capture those dimensions in a view. I can just go say capture my 3D view, and we got that there. And so now we have a 3D view that has those dimensions. Per 3D view, you can control which dimensions, which notes, whatever is going to go in there, and you can define each one of these guys to different annotation views. And then you can say per your captured 3D view, which ones are they looking at. So it makes it real nice to be able to organize it that way and just kind of clean it up. I just put that in a different view, so that's why it doesn't show up anymore. Okay, so with that said, let's go ahead and save this as a step. So here's the step 242, and I'm just going to go ahead and save this to, save it to the desktop. I'll just dump into this folder. It's like I already have one that's overrated. So something like that. So we have that step 242, so it's going to be a step file with those dimensions in that file. And now if I were to then publish a 3D PDF, I can choose whatever template we want. And then the little option here for the new option is attach files. And this is huge. So we can go ahead and say, let's attach to what's new document, let's attach this random document, Word document, there's a step file, maybe some other images or videos or whatever you want. We're just going to take these files and embed them into the PDF. So when you send the PDF to somebody, it has a PDF extension. So it's going to bypass email, the virus scanners and things like that, which something like an EXE wouldn't, which makes it more difficult. So being a PDF format and embedding things into the PDF is really nice to be able to send a package or receive a package because it's a very common tool, and we can use it almost like a zip file now, where if you send it and somebody has Adobe Reader, that they can extract the files out of the reader, which is really neat. I really like that. So we'll say yes, we want to include these guys, and let's go ahead and save it. Another thing I want to point out here, this isn't new, it's just all those fields inside that template that we're messing with. If you edit the fields, you can populate those with your metadata, which is pretty cool there too. Okay, so let's go hit the checkbox and let's put it in this guy here, PDF, like that, boom, and we've embedded that. So now if I go to that location, which is right here, gear plate, you can see it's still a very small file size. Has all that stuff in there. That PDF's making it large. That's why it was over 7 megs, because that PDF is large that I imported. And there is my view. If I had any additional views, they'd be down here. And then right here we see our attachments, and I can go ahead and I can, bring up any of these documents here, which is, it's just a really cool enhancement. I think that's my favorite one for model-based definitions. Okay, so back to the PowerPoint. There's quite a few things for model-based definitions. I couldn't fit it all on one slide there. This one's kind of roll off the other. We're just going to go through these real quick. So name match in 3D PDF. So so your dim export naming from SolidWorks, from when you actually create that in SolidWorks, that now the same names come over into model-based definitions in that 3D PDF output that is saved. So the naming structure stays consistent, so when you spend the time to create your names, they actually fall through down to the 3D PDF. So really nice that works now. Reordering 3D views. So when we are in SolidWorks there and we have the 3D views at the bottom, you just take and drag those anywhere you want. It repositions them, so when you save out that 3D PDF, they're in the correct orientation. So sketches display in 3D PDFs. So now when you create that 3D view, if you have any view sketches visible, those sketches will actually go into the view. If you don't want the sketches, just hide them. The sketches can be really nice to have there, especially like say you're doing like a sheet metal component, you want to show a bend line. Now you can go ahead and just snap a line to the sketch of that bend line, or use the one provided with sheet metal and actually display that sketch in the 3D model, so you can see this line saying, oh, that's where it bends, or that's where a decal goes, or it's just a sketch to kind of define area and show things that we just couldn't before. So that's a really nice enhancement there. Now the comparing 3D PMI between parts, another good one. So we can actually take multiple parts and say, hey, what has changed with these? So let's go ahead and show that as well. So what I'm going to do is just shrink these guys down. Let's go Tools and compare 3D PMI, new guy there. And so now I'm going to go ahead and pull in kind of the same component, but different configurations of each. So now if I go turn comparison, there we go. So we look at these, and they're basically the same model, right? So the real estate kind of shrunk down here a little bit, but you'll see that there is some model changes between the two. Most apparent is this guy is a bit longer there. So now if I go say, hey, what's unique between the two? It's going to expand this so we can actually see it a little bit better. Unique data, modified data. So anything purple is unique between the two. So that didn't change. Anything green was modified, especially, you look at these guys here. They changed, and that's the unique data. Okay, so again, another nice little tool there for comparing what has changed. All right, so going on to the next thing on the agenda, and we're talking about SolidWorks Visualize. We've got quite a few things in Visualize that are really exciting. I want to save this one for the last because it is a fun product, and it is my newest product here at Hawkridge that I've taken over, and it's really fun. So it is a photorealistic rendering tool, to say the least, and it runs off of iRay. If that makes any sense, or if you guys know what that is, or if you don't, what iRay is the rendering engine that powers Visualize. Most rendering engines out there in the market currently are typically V-Ray, which only uses your CPU power. Where iRay, or for Visualize, it actually uses both your CPU and your GPU, which just blows the competition away because GPUs are much cheaper than CPUs, and you can get a whole lot more performance out of them for in a lesser machine with less money and super fast renderings. For comparison, I was doing a rendering yesterday that on CPU was going to take roughly 6 hours. I did in 15 minutes with enabling the GPU. So I mean, it's so much faster. It's just mind-boggling. So, and we'll show that here in a second. Installing first thing on the list. Sorry for rambling on about it. It's just pretty exciting. So first thing on the list here is SolidWorks Visualize now installs the same way SolidWorks installs. So when you go to install any of the SolidWorks products, you plug in your serial for Visualize, and all of a sudden you'll get an option now for installing Visualize through the same installation manager, which is nice. You don't have to go out separate from that trying to find the file and download it and install and all stuff. So it's included with the family, which it should be. Context sensitive help. So now any dialog boxes that you're in while you're working in the application, which I'll show here, and you hit F1, it actually pulls up the help menu for that specific thing, which is really convenient. And I think all programs should work that way because, if say that we're in a rendering and you're like, well, what does this stuff mean? So I'd then load up the help menu. I would type in rendering or something and try to locate this and then get the help for it. If I hit F1, it's going to pull up help and it's going to say rendering tab. What does this stuff do? And it's going to be all right there. So super helpful. Every program should work that way. And it's kind of leading the pack in that manner there. And so that's really nice. Okay, next is creating a section views. So this is fun because, we could do this in the past, but you'd want to create a configuration in SolidWorks with the section cut, bring that in Composer, bring into Visualize, Composer as well, and then show that and render it out. By the way, you can do cut planes in Composer. But so with that, we'll go ahead and show it. So basically, we go into Visualize, and while I show this, I'm going to show one other thing that isn't in the PowerPoint, wasn't on the list, but I got approval yesterday to show it because it is going to come out, hopefully Source Pack 0 of 2017, but I wasn't only approved to show it, but actually encouraged to show it, and that's called Power Boost. And I'll show that with the cut plane to show how fast it is. So right now you'll see I'm on preview mode. So if I were to go to this guy here for accurate, it would bog my computer down. This computer I'm on right now is a laptop. It's not a new computer. It's fairly old. I think I've had it for 4 years now. It's an i7, 16 gigs of RAM. I mean, it's decent. It's got a Quadro K1000 video card, which is like, if you go on eBay, you can get them used for like 25 bucks. And so it's not anything spectacular. And so what Power Boost does is it enables to steal the power from other computers on the network. You set that up so you're not going to go and steal your coworkers, computing power without them knowing. But basically, I'm going to click on that. It's going to take a second so I can easily connect to my server. But on my network here, I have a computer we built. It's not a super fast computer. It's a decent computer, but it has 2 NVIDIA grid cards in there. Each grid card has 3,000 CUDA cores, so it's running 6,000 GPU cores on this machine. And since this is iRay, it's going to utilize the GPU and the CPU of that machine. So on screen here, live, I can rotate and do whatever I want, and it's going to render live as if I was going to render this out into an image. And you'll see the passes here. This is passes of the rendering. If you've seen rendering in the past, you get these little blocks that go through and they kind of like render it out piece by piece. That's not what's happening here. This is rendering as those blocks are going through super fast, but this is the whole image. So right now I have 300, 500, 600 passes on this rendering. So right now this rendering would be good enough to save out. I control things like shadows a little bit dark, so I'd probably adjust that. But basically, we got 1,000 passes. 1,000 passes on a rendering, I mean, you're talking hours for that rendering to output, where I just did it in like 30 seconds. So it's super, super, super powerful. Okay, so let me go ahead, and I just didn't like that shadow. I think it's a little bit intense. Let's turn that down. Much better. Okay. All right, so moving on to what I was supposed to show here, and that's the cut plane. So what you do is you go to Models. Here's the cutting plane. Shows that cutting plane, and the cutting plane works just like any other element where I can take it, I can move it around, and we can show that. And you'll see it's rendering real time here. So the passes restart every time I move something. I can go ahead and change that at an angle, move it around, something like that. Let's go ahead and zoom in. Let's take a look at this guy. We'll do a cutaway rendering there, something like that. Shadow's a little bit dark. I'd probably turn that down, but yeah, so there we go. We'll just give that a second so it renders and it just keeps getting clearer and clearer. So that power boost is awesome. The power boost works for both working in the application and rendering out. Rendering out technically is a different product. It's called Boost. They both work the same way, but they are technically 2 separate applications, and I'll talk about that here in a minute here. But let's go back to the PowerPoint, and we'll get to Boost here in a second. But using SolidWorks camera navigation and shortcuts. So if you're familiar with SolidWorks and you go to Visualize, and all the navigation and stuff is different in Visualize than it was in SolidWorks. So now you have the option to setting them the same. So when you're working in SolidWorks, you go to Visualize, everything operates very similarly. So that's really nice. Okay, so the home screen, when you first open up Visualize, now SolidWorks Visualize, now it has more options. It has like previously opened products, it has tips of the day, it's got website links. If there's competitions going on, that might pop up there. It's kind of this, I don't know if you've noticed that Chrome does this now, and you open up Google Chrome and it says, recently viewed pages, or these are your most popular pages you'd like to go to. Just making life a little bit easier, kind of commonly used things that pops up when you first load the application before you load any projects. Pivot point snapping. I can show this too. So before the pivot point, when you're moving it around, let's say that you had a door and you want to put the pivot point on a hinge, so when you rotated the door, it rotate on the hinge. It was really hard to know where exactly you're putting that point, because you might look like you're putting the hinge, but you're actually putting it way behind or way in front or way off to the side, depending on your perspective. Well, now it actually snaps to the model, which makes pivoting a whole lot easier. I just realized there's like a little Hawkridge chip in there. That's pretty cool. Okay, so let's go ahead and change this to just a selection. I just want to select a model, and so let's do this guy. Yeah, this guy here. So we got a part, and so let's say I want to rotate this component. Now I go to pivot, and where's the pivot for it? Well, let's locate where the pivot is. The pivot is way down here. I don't know why it's there. It's probably the origin of the assembly of that. Oh, it's probably created in place, and so it's the origin of the assembly it was modeled in. And so now if I were to go and I take this pivot point, I can just take the pivot point and I can move it to the model, and I'm assured that it's actually snapping to the model, which in the past you'd want to grab these things, you want to kind of move them around and change the angle, maybe do like 4 viewports so you can see like top, front, right, and then try to move it around. It's really difficult to move. Well, now you just move it and you'll say, you know what, it's going to snap to the model, so we'll snap it there, and let's go ahead and now rotate that part along that pivot, something like that. Keep in mind I'm still rendering at photo quality, and so that's why it's a little bit laggy. But it is super fast still. I mean, it's laggy for a real-time application, but it's still super, super fast. Something like that. I'm not really sure what I selected there. I think I should have selected a different part, but I think you get the idea. Okay, moving on. So that is the pivot point snapping, so super convenient for creating those pivot points, which is going to make animation a lot easier too, because that was the biggest gripe in the past with pivot points, is animation relies heavily on pivot points, and if the pivot points aren't easy to use, animation isn't easy to use. So now that pivot points are simple, animation's a whole lot easier. You just click on a point, rotate that, animate it, done. Okay, so rendering output using Visualize Boost. Okay, so we're finally to the fun stuff here. So this is awesome, and me try to explain what this is. So Visualize Boost enables you to, essentially it's a network farm rendering. So if you have a computer or a group of computers, you can put Boost on these computers, and they will be networked together utilizing their GPU and their CPUs. And if you have your work computer, in this case my laptop, and I want to create a bunch of renderings, but I still want to get work done, I wouldn't want to do those renderings using the power of my laptop. I use my laptop to put together the project, but if I'm going to, render out an animation that's 5 minutes long at 30 frames per second, and each one of those frames are 1,000 passes, well, that's going to take a while to render out. And if I'm rendering that on my laptop, I'm not going to be able to do other things because it's going to be hogging its resources. So networking these machines together, or getting a more powerful machine with some good CUDA-enabled cards, and I say CUDA because that's what iRay supports. It's NVIDIA CUDA, so that's a lot of your Quadro cards, coupler cards, grid cards, and all those guys, they have CUDA cores. You can easily research to make sure that before you buy a card it is CUDA compatible, and then it utilizes that super fast. You still do the rendering on your computer, which is cool, so I can render this to my desktop, but it doesn't take the power of my machine to do so. And I'm not really going to render too much. Actually, I can. It just takes too long in a presentation. I got 6 minutes left, so I kind of want to open it up for questions and answers. So, but I'll show what I would technically do. So we want to make sure that the boost here in the options, Frankenfarm, that's my rendering computer. We took a bunch of other computers, took them apart, built this guy, so we'll call him a Frankenfarm, and you'll see that it's connected. Right now it's rendering because I'm using Power Boost, which is fine. But what I'll do is I'll go ahead and switch this, so I turn Power Boost off, and then that frees up the server. You would still technically use it. I say free it up, it would use it, but it wouldn't be as powerful because I'm using it more than once, which I do often, but this way you use the full power of it. So now if I just say render, and I say, well, I'm going to go and use the cluster, which is the farm, and I'm going to go ahead and start rendering that out, and I can render this out super fast. This right here at this settings, I think it takes 1.5 minutes, so it's super quick, but 1.5 minutes I really don't have right now. Okay, going back. So that is Boost. Boost is awesome. Power Boost is great. Power Boost you'll see coming out here shortly, what I've been told. And so Power Boost, it speeds up your operations as you're working in the application. Boost speeds up your operations when you go to render it out. So that's the difference between the two. All right, so now for the add-in for SolidWorks, this is pretty cool here. So, and this is actually one of the even bigger than Power Boost, in my opinion, for really cool things coming out or that are being released. So, the ability to export motion studies from the SolidWorks add-in. It's awesome. So your SolidWorks animations that you might have, or if you want to set up an animation in SolidWorks, then you can actually use the Visualize add-in for SolidWorks that comes with Visualize to just export that out into your Visualize project. But that also exports your geometry from SolidWorks, the appearances, any HDR lighting from your scenes, decals, which is great, right? Because you don't have to re-put those decals on and Visualize, and then also your animations, your motion studies. So if you have gears and motors and mates and everything that are running this animation, and you can push that out, bring to Visualize, render it in photo quality animation